The broadcast is now starting. All attendees are in listen-only mode.
Hi, everyone. We're just at 1 o'clock here. Thanks for joining. We'll just wait another minute and let the others join in. I think there's a few more people that we're expecting. If any of you have Zen Lite or have downloaded the 90-day trial, feel free to have that open as well. You may find some things that you didn't know existed. So feel free to have that open, might be helpful. All right, so it's 101. A few more have joined us, so I think we'll get started. Let me first start by introducing myself. My name is Nicole Kuntz. I'm the account manager supporting Southwestern Ontario for Carl Zeiss Canada Research Microscopy Solutions. Thanks again, everyone, for joining us today. As you know, we're going through an Explore Zen session online. Myself and your local imaging specialist, Dan Stevens, will be your host today. I'm sure that most of you here, sorry, Dan, for interrupting. I think most of you are already Zen users and probably have some experience working with Zen Lite or Zen Blue on any of our imaging systems. So hopefully going through some of these different aspects of Zen Lite, you'll learn that it's actually more powerful than you think than just looking at your images. And also you'll likely learn a little bit more about how to take advantage of the time you have when you're on an imaging system with Zen Blue as well. So Dan will chat about some of the things we'll go through today.
And we should mention also that there is a little poll or a little survey at the end of this. There's 3 questions. 2 of them are yes, no. One of them is there anything else that you'd like to see that wasn't presented today? We'd really appreciate it if you provided your feedback because we're doing this for the first time. You are guinea pigs somewhat. And so the responses that we get are going to direct us in terms of how valuable this is for you and how much effort we should put into repeating this or looking at including other topics. So we'd really appreciate it if everybody who attended provided their feedback, good or bad, so that we could do what's best for all. I think we covered all the bases then. Nicole, should we?
I think I'll just add one more thing. There is a chat window that you guys are free to use to type questions if you want. If you're experiencing any issues, let us know so that we can, be up to speed with whether you can hear us and whether the screen is frozen, that type of thing. So questions, issues, feel free to use the chat box.
And please do. This is intended to be rather informal. It's not quite the same as our larger Zeiss on Your Campus presentations. It's much more of as best we can, as if we were sitting beside you showing you these little bits. So, okay, great. We begin?
Let's do that.
Okay, so we're going to start with some very basic functionality of Zen Lite if we have a captured image. A lot of the times we're going to be using this flow cells #1 slide from Life Technologies, which is short form BPAE, bovine pulmonary arterial endothelial cells. So Nicole, if you would open that guy up. We've got some quick buttons at the top here to get our images open as fast as possible so that we're not hunting for them. And that's the first thing that we're going to do is demonstrate what you might want to do when you capture a series of images. So we've done an imaging session. This is actually a 3x3 tiled image, so we're going to use it as the basis for what we would get if we captured a series of smaller images. Let's do a little crop of this, Nicole, if we could. You grab the ROI tool from the bottom in the graphics panel there and draw an ROI in the image somewhere. And when you're finished drawing the ROI, let's point out just at the bottom of the image, there's a checkbox that says show all. And that's common for a lot of windows in Zen. If you ever want to do anything and you can't find the tool, make sure that you've got the show all checked off. I would say that I'm not checking it off all the time, certainly, but there are a few situations where there's something hidden that you might want to use. And this is one of those. So if we check it back on, then you can see down in the graphics tab window again, in the bottom right-hand corner of it, there's a width and a height associated with this crop region that Nicole's just drawn. And if you click in there, Nicole, you can specify an exact width and height in pixels, or you can toggle it to be scaled in microns. And I don't know about you, but it would drive me nuts to have a figure that had a width of 1,839 pixels. So I would like it to be a nice round number. Now that we've got that squared away, then we can right click on the ROI tool and say create subset 2/3 of the way down the window, and we will get a subset from this. And that will pop out a new portion of the image. Let's do that 2 more times, if you would, Nicole, in different areas, and then we can use those images that we do as subsets as the basis for creating a figure. So the ROI tool, oh, you got to select the ROI tool again.
Oh, right, my mistake.
There you go. You can, if you want to, set it and then copy and then paste it after you've set it. So if you do your 2200 and your 2000 again, instead of drawing it every time, you can now Control C and Control V, or right click on it, I think, and copy paste. I'm not sure about that. I always use Control C, Control V. There you go. And that lets you, gives you another ROI, and you can just drag that to another region of the image if you'd like.
Perfect.
That
okay,
works.
yeah, I just did Control C, Control V to get my second ROI. So I'll just open up these guys as another subset. So we've got subset ROI 2. And I'll go back and open subset ROI 3.
Great.
Great.
Okay. So this is 3 images that we're going to use for one of my favorite tiny little hidden features of Zen that for some reason we don't seem to be able to get across to people that they should be using, because everybody loves it when I show it to them. And that's what I call the figure maker. It's officially called the multi-image mode, I think, or split image mode, but it's this bookmark or this open book icon, there you go, that we have a mouse.
Right here in the middle.
Yep, multi-image splitter mode. So if we click on that, it's going to propagate another tab in our window here, and we're going to see that there's 2 spots for images. And we can modify that so that there's as many as 4 columns and 4 rows if we want to. We have 3 images, so we'll make at least 3 columns. Maybe you could add another row in just so we can show people what it looks like. There you go. And when we want to populate this, we're going to drag the images from the right-hand side thumbnails into these image windows. And the nice thing about that, I'll wait till Nicole has those populated, is that once you have your images in there, if you zoom in and out by mousing over these images and scrolling the mouse wheel, then you'll see that they are synchronized. And they're synchronized not just spatially, but they're also synchronized in the display. So if you were to change the display to min-max or change the brightness contrast, it synchronizes that. And you can desynchronize them if you want to. Oh, there you go. So on the right-hand side, where it says synchronize dimensions and display, you can uncheck that. You can reposition things if you'd like to. And just get everything set the way you want to before you create a figure. And then we're going to hit that create button, not just quite yet though, Nicole, and that'll give us a multi-panel figure all done. I said not just quite yet because somebody in the last session that we trialed yesterday had a question about creating spacing between the panels. You can see at the bottom of this split display window that you can in fact change the spacing. So there, it says spacing 2 right now, and it says spacing color black. So if you click on the spacing color black, you could change it to white, for example, to make the panels more distinct from one another. That's it. So we create a figure from that. And I don't know about any of the rest of the audience, but I have spent a remarkable amount of time in Photoshop and Illustrator cropping and positioning individual images in order to get them to look exactly like that. And it's time that I have not learned anything from or benefited me in any way other than to get the result. So I use this figure creator all the time when I'm providing people results from their demos, or if I'm doing a tutorial like this and I'm trying to compare A with B. And we're going to do that later on today with some of the image processing we do. Good.
Great. That looks awesome. I know I've spent way more time than I needed to in PowerPoint trying to make everything equal. So
Yeah.
this is really handy.
When I drop these into PowerPoint, you can, of course, just save it as a JPEG, but I'm even lazier. I just use the Windows snip tool. So if anybody listening is not using the Windows snip tool, it's definitely worth exploring. It's a screen capture device, and you just kind of drag, and it saves even that step of saving a JPEG and then importing it, because it copies and pastes the image on the screen more or less. All right. We've got our multi-panel figure, but probably we want to add some annotations to it at some point or another. So why don't we go back to one of these images that you've cropped out previously, Nicole, and we'll add some annotations and discuss just formatting and then doing some measurements. How's that? Sound
Perfect.
good?
Yep.
So we'll start with the text tool.
All right.
It's
right here.
Yep. Text tool in the graphics, quick access bar. We type in something, anything that we want to do. Great. And so we've got some text on here, but that may or may not be the right color and size and shape and all the rest that we want it. So if we right click on any annotation that's in an image in Zen, we can format those graphical elements and change every aspect of that. You can set it however you'd like, Nicole, and I'll point out that once you've changed this to be the way you want it, if you'd like to keep it that way, there's a little button in the bottom left-hand corner of that dialog window Nicole was in that says set as global default. And if you set that as global default, then you don't have to change it time after time. It'll be there each time you use the same tool. So if we use the text tool again, then it would look the same.
Where is that again, Dan?
Yep.
Where is that?
If you right click and say format graphical elements.
Ah, here. Okay.
The bottom left there, set as new global default. Yep.
There it is. Yeah.
So if you click that now, then the next text you'd put on would also be 72 size. I meant to say before, well, actually, let me follow up on this when we put a measurement tool on. So let's go from an annotation, a text annotation, to a measurement, Nicole. So we'll do a square tool or a circle or any sort of other measurement tool that's in the graphics quick box there. Yeah.
Sure. Let's
draw that somewhere on the image. So you can do the same modification of your text, your font size, etc. On this, but you can also change the measurement features. So if we right click now on a measurement tool and we go down almost to the bottom of our list, you can say choose measurement features. And when you select that, you will get this window pop up that has a rather extensive list of features that you can measure on the right-hand side of the window. Anything that you want to add there to the measurement, you can just double click on and it will add it in. We have right now by default the area, the intensity mean value, and the diameter. Let's add at the very bottom of that list is intensity standard deviation. Let's add that, Nicole, just for the sake of having something else. You see that there? Yeah, standard deviation. And then
there we go.
It's going to make the image rather busy. So if we look in the second column that has all of our annotations, what we're measuring, you can see we can toggle off the display. So let's, I don't know, toggle off any number of those, Nicole, so that we can see that we're not going to annotate the image with those. Great. I say OK, and we will see the new measurements here. Now, where do we get the measurements if they're not showing up in the image? On the left-hand side of the image, there's a series of tabs, the bottom of which, second last one is measure. On the left of the image there.
Right
Yeah.
here.
Right
Yes.
there. So when we click on measure, we get a table that pops up beside the image, which has all the measurements from all the tools that we've used on the image. And that table, you'll see, has the channel 1 mean intensity, channel 2 mean intensity, all the measurements that we've taken there. The purpose of that table really is that we can get this data out of Zen. So in the toolbar that pops up when we're in the measure tab at the bottom of the image area, there's a little tab that says measurement there, Nicole, right below the image. And the bottom of that toolbar, it says create document. So if we create this document, we will now have a table that propagates. Go ahead and make that, and we can show people that we have an independent table. So this is no longer attached to the image. All the measurements we take are going to be saved as metadata with the image. You save the image, the measurements stay. Now this is disconnected from the image, but it means we can export it. In the bottom left-hand corner of this window, we have an export table, which spits out the data as a comma-separated value that we can then open with Excel or OpenOffice or anything that we want to import that into. Zen has some rather extensive graphing features, but I have yet to meet anybody in academic world who wants to do graphing in an image analysis program. Everybody pretty much is using Excel, so that's what I do. All right, good. So we've got some measurements then. A couple things to point out there. If we go back to the image with multiple annotations, I wanted to mention that if you just click anywhere in that image away from your annotations, Nicole, if you use any of the Microsoft shortcuts, so Control A will select all of your annotations. If you click on an annotation and then you click on another holding the Control key, it will select both. If you shift click, it will select the range. So anytime you have either a table or annotations in an image, you can use any of these common Microsoft shortcuts within Zen. And that can be quite helpful if you start getting a lot of annotations or a lot of entries in a table. Should also point out that we added a couple of graphics that are in the graphics quick access bar at the bottom of the image, but there's also a graphics entry in the file menu bar in the top left. And there's quite an extensive number of tools there. We're going to come back to that. And well, actually, let's just mention now that any one of these you selected that's not in the quick access, if you were to annotate it on the image and then right click, so let's just right click on the circle if you would, Nicole.
Sure.
And we can add that to our custom graphics. So the very bottom of that list that pops up, if you say add to custom graphics, then we have a custom graphics tab at the bottom of the image. And now we have a new circle tool that's added to that custom graphics tab. Just an inch to the left. There you go. Yep. Awesome. So that prevents you from having to go up to the graphics menu and reselect the tool and come back into the image, and you know it's right there, ready to go. You can even click on Keep Tool, and then it'll allow you to just draw multiple annotations if you want to in the one image. Okay, what do you think? We covered the manual annotations and measurement. I think so, right?
Yeah.
We have a question here. I have to expand this question window. So there we go. Oh, okay. My apologies, folks. We have a number of questions. I thought I was watching, but it didn't notify me. So what resolution was the raw image taken at? 2048. Nicole, if you click on the info tab of that original BPAE image, remember, this is a 3x3 tiled image. So I forget what the individual tiles were, but it's looks like 5841 by 5813. Some of that is stitching. Oh, I've got an incoming call on my home line. Please ignore. So that's not exactly what the individual frames were, but I hope that helps. That answers it.
Call from Penryn.
if we go to the 2D version of that image, we can answer one of the other questions, which was how to set in a scale bar. So Nicole, we've got a scale bar entry there as one of the annotations. There you go.
Yeah, you'll always see it here as the mini ruler in the graphics. So
there you go.
that will insert your scale bar, and if you need to change your scale bar, again, just format graphical elements. You can change the thickness of the line as well as the text.
Yep. And save as default, again, if once you've got that sorted the way you want it. And I had intended to mention, but thank you for asking the question, everything that we are showing here, with the exception of the image analysis at the end, is available in Zen Lite. And as I say that, I have a question that maybe one other tool that we're about to show is possibly not. But really, if you look at the agenda, which I think we've handed out and is available in the handouts on your webinar toolbar, if you want to reference it, all those functionalities that we're showing are really Zen Lite. So the intention of this was to tell people functionality that they have currently and are going to always have, that's available to Zen Lite. Okay, good. Will the scale bar or any measurements that you add carry over to that image that we can create? I'm not sure what that means, the figure. Oh, yes, the annotations will carry into the figure. Sometimes the scaling doesn't look right and it can be a bit annoying. So it's a little bit finicky, I'll say, and we won't go through showing that, but absolutely the annotations will show up in the figure maker. You can use that as well. You can, of course, annotate the figure once you've created it as well, depending on what you want to put in. Good. You're welcome. Thank you. All right, so we've done some manual measurements. Let's do some other types of measurements. I got a couple more that I want to go through. So something that I get asked fairly often is, how do we measure the size of something in fluorescence? In particular, this is usually a boundary or a small object, because it's not obvious where the edge of an object is when we image in fluorescence. So to demonstrate that, we're going to close all of these images and open up a set of beads. There's a couple different ways you can close your objects that Nicole's going to show you. You can right-click and say close all in your shortcuts.
Highlight them all.
You can highlight them all, sure. So there's the close all is there.
Ah, right, this.
Oh, you had it when you right-clicked. You were correct. The right-click was the way to go. You can do it down there as well. There's a lot of different ways to close them all. Yeah,
right.
We close all our images there. Go ahead. You can close them all, and you can never close an image that you haven't saved in some way in Zen. So we have to explicitly say no, we don't want to save these. Thank you very much. You can also right-click on the tab that represents the image. And you can go to the file menu bar and go to window and close all as well. And I think there's a hotkey, so lots of different ways to do it. Yeah, Control-Alt-W. So let's open up the bead image, Nicole. So this is a Z stack acquired of beads. And we're going to, if you just crop out some field that has a couple beads in it, Nicole, so we don't have to worry about the whole thing. We're going to measure the size of these beads, and it's a good example because it's not obvious what the size is by just slapping a scale bar on, which we'll see in a moment when we zoom in. So we create a subset and then zoom into one of the beads. So if you want to zoom in and out on Zen, if you mouse over the object you want to zoom into and then you use the mouse wheel, it will zoom you into where you're pointing on the image. Let's adjust the brightness contrast on this, Nicole, to just by saying min max.
Oh, sorry about that.
Okay.
Sorry about that.
Yeah. So for the folks watching, there's a slight delay for Nicole. So she is not only doing all the mouse driving, but she's also dealing with a kind of half-second lag. So if an image flies off the screen for a second, it's because of the lag that Nicole's got to contend with. So now we're looking at this bead, which is sub-resolution, so under 100 nanometers. And you can see that there's no definitive boundary there. It's just a fuzzy ball that has a gradient of intensity from peak to the outside. And by default, when we zoom, Zen interpolates pixels to keep them kind of smooth so we don't get pixelation of the image. But if we really want to see what this looks like, under the dimensions tab just below the image to the left there, Nicole, if you would toggle off the interpolation, there we go. And now we see, yeah, so this is really clear now that there is no definitive boundary on this bead, right? So how do we measure that? Well, we're going to use a tool called the profile tool, which is on a tab to the left of the image. And we're going to use that profile tool to determine something called the full width half maximum of the bead. So what is a full width half maximum? Well, it's exactly what it says, but it's a mouthful, so I'm going to step through it. So it's the full width of the size at the half maximum intensity. So zoom into one of those beads, Nicole, in the profile tool there. I don't think it matters which one. And let me know if you need a hand scrolling. You got it.
There we go.
Good.
That's fairly centered.
And then we have the idea of the profile tool is that we're going to get a profile of the intensity of the object. So in the bottom of this image, there's a profile definition window, and that gives us tools to draw on the image. So we're going to pick the line tool, which is picked by default. And if you toggle it again, it'll turn it off. So I think you should be set. There you go. Click on it, and we've got a line tool. So now draw a line, Nicole, if you would, right through the bead. And we will see on the plot window to the left-hand side of the bead, as Nicole draws through, we will get an intensity profile. Perfect. So here's the intensity profile. That means the x-axis here is the lateral displacement. So that's the pixel by pixel as we go across the line. And the y-axis here is the intensity of each one of these pixels. We can see that the peak of the intensity is reached at about 2000, 1998, fair enough. So that's the maximum. The half maximum then is about 1000. And we want to figure out what the width of the bead is, or the width of that profile is at 1000. So we have a little tool to use with the profile window, which is called the caliper. In the profile tools at the bottom, we can select the caliper, and we can then go up to our profile, and you can actually zoom in on the plot, which makes it a little easier to use the caliper tool just by scrolling the mouse wheel. So any plots in Zen you can scroll in and out of, and you can also draw a window on the plot area, and it will automatically zoom and adjust the axes of the plot. So Nicole's going to go and find that intersection of the profile with the 1000 point. Uh-oh, we've taken our data off to the side. That's okay. If you click without seeing it, Nicole, and just finalize it and then zoom out, you'll be able to move it again. So you can adjust it.
There we go.
Yep. Click and drag, and we've got, terrific. So the distances you can see above the plot area go from 1.52 to 1.81. Those numbers are rather meaningless as an absolute, but the difference between the two is 0.29, so 290 nanometers. So the effective size of this bead is 290 nanometers, measured as the full width half max. So why is that important? Why did we do it that way? Well, you can imagine if we did an exposure time that was half of what was done to collect this data, so that the intensity was half, then when we go to look at this plot, the maximum intensity will be 1000, the half maximum will be 500. If we measure the full width at that half maximum of 500, we should find out that the bead is still 290 nanometers. If we did something that was based on an absolute intensity, then as we change the exposure time, the apparent size of the bead would change if we were thresholding based on some pixel intensity above background or something like that. So a full width half maximum is an intensity independent method of measuring the size of an object in fluorescence. Okay, that's it for our measuring
Great.
with our profile tool. Do you think we got everything there, Nicole? That makes sense?
Yep, I think so. Yep, that makes sense.
Oh, maybe we should mention that we can add that measurement to the table as well. So a little button there that says add to table. If people were measuring a bunch of these, they might want to keep those measurements.
Ah,
So same
right.
as before, we add to table and then we can export the table and we can have our data independent of the image if we'd like. Good. Okay. I don't see any questions on that in particular, I think. Let me double check here. Sorry, steal the mouse from you, Nicole. There we go.
No worries.
So let's move on. We're going to use the profile tool again, but now we're going to measure some dynamics with the profile tool using something called a Kymograph. So we can shut these images down and we can open up a particle tracking image. And let's take a look at that. So what the image we're about to open is a super resolution image of a subcellular region of a single cell. So this entire image is something like 4 microns across. And what we're seeing here are particles moving around. This was captured at over 100 frames per second as well. So you're seeing really small things traveling actually very quickly. And it's just a really nice biologically relevant thing that we want to take a look at how quickly these particles are moving. In particular, we've cropped in after Nicole did some trial and error and some picking of particles. We've cropped in on this guy who's traveling from kind of 6 o'clock to 11 o'clock vertically. You might see that. So Nicole's going to draw a line, a profile line that proceeds along the path of movement of this particle. We want to start by selecting the, oh, you're going to reduce the frame rate a little bit?
Just a bit.
I want to give Nicole some buffer room on her performance here by reminding everybody that she's doing this on a moving particle of nanometer size with a lag on the webinar. So it can be challenging. So let's select the profile tool to the left of the image there, Nicole. And instead of the straight line tool, you're going to want to select the freeform tool just to the right of where your mouse is. Yep, perfect. And I don't know if you want to resize that area by reducing the size of the table by dragging that, or does that help?
Make that bigger.
Yeah.
Okay. There we go. That's much better.
Good. So as we play through this, Nicole's going to trace the path of the particle movement. We'll wait for her to, I think you're doing beautifully. Terrific. Perfect. Right click to end. And we see the data immediately on the left-hand side. So we're seeing this giant peak in the profile, and that peak is moving along the x-axis as you would rather expect that it would, because we're seeing a time series. So we're seeing profile after profile after profile through all 76 time points. And that gives us an idea of the movement of this particle, which is great when we look at all these individual time points, but how do we capture that as a single data set? So under the processing tab on the left-hand side of the Zen window, under methods, let's search for Kymograph, which is the method that we're going to use to display this time series as a single image. There we are. So if we select Kymograph and we look under the parameters tab just below, we can see that we have a graphics tool to select. We only have one graphics annotation on the image, so it's automatically selected for us as spline curve 1. We can change the width of the curve if we want to. So we traced a single pixel curve. If we increase that a bit, it reduces the noise, the variation that we might get. That makes it a little easier for us to make sure we're hitting the trace. There we go.
It's probably a bit better.
Yeah, I think so.
Yeah. I think so.
And now we've set our parameters, we can apply those parameters and we'll get a Kymograph spit out, which I will explain what that is after we have the data up, because it's easier when it's in front of us. Terrific. So we've got an image that represents the movement of this particle. What you're seeing is a displacement versus intensity image. So the x-axis is displacement. So it's actually moving along the profile that Nicole drew. And the y-axis is the individual profiles. So you're seeing the intensity of each line, each row of this image is a different time point. And then we're marching through those time points. And so we're seeing the displacement of the particle along the trace. We see the particle disappears at some point, which I think is just maybe our tracing wasn't exactly on, but Nicole did a great job, and we can pull the angle off of this. And because the angle will give us displacement over time. Remember, one axis is displacement, the other axis is time. So rise over run is the angle or the slope of the line. We're measuring the velocity of this particle, right? Did I say that in a way that I felt like maybe that was unclear when I said that? But I think that was clear, Nicole?
Yeah, I mean, it's just with the basic geometric equation that I'm sure we all know. Have to pull back in the memory, but yeah.
Good. Terrific. And I should mention that there's an angle measurement tool under the graphics bar in the file menu. So if you wanted to do that,
Yes.
then yeah, all the way at the bottom of the list there pretty much is the angle measurement. Terrific. So we used the profile tool to measure the width of a bead. Then we used it to determine the velocity of a, oh, okay, we're measuring angles.
I just,
That's cool. So we wanted that one to run along the axis, I guess, right? The y-axis to measure the angle. So straight up and down.
right.
Yeah.
Yeah. Anyways, I think they get what I mean here.
Yeah.
I just wanted to mess around with that, but
Very good. So let's do now some more intensity measurements. So let's go back to our BPAE slide, if we could, Nicole. I suppose we could have reordered these and then we would have been more efficient with the opening and closing of the images, but that's just occurring to me now after running through this multiple times. Okay, so the BPAE image, yep, and let's crop out a smaller region of this just to have the display more manageable. We could zoom in, whatever, doesn't really matter. Let's say that what we were doing previously was we were drawing manually around an object of interest and getting the mean intensity of that object, which is fine, but it's a little tedious. And if you're drawing around things the way I'm drawing around things, it's also not terribly accurate because the boundary of your object may not be so exact. So we're going to use a more precise way of doing this, and that's to threshold on the objects of interest. We're going to look at only the nuclei just for the sake of ease of understanding what's going on here. So let's make that a single channel display. Perfect. And then we're going to use the histogram tab that's sitting on the left-hand side of the image. And that histogram tab, when we click on it, will give us a whole slew of data. But at the moment, it will be all related to the entire image, not individual objects in the image. So may be of interest, but it's not going to give us the mean intensity of each nuclei. We see in the top left is a plot of the frequency of intensity for each one of the intensities. So it's a basic histogram. Just below that, on the far left data table, is the frequency data instead of the plot. So the plot and the data go hand in hand. And then we have a number of statistic windows, and then we have some measurements which are empty currently. We can simplify this by going down to the Histo View tab below the image area. And for our purposes, we don't really need the the frequency table we don't need, and the interval measurements we don't need. There we go. Terrific. So we can now see in the data table that it's immediately below the image, that the top line is the mean intensity of the three channels, then there's the variance of the three channels, the standard deviation of the three channels, et cetera, et cetera. So all the possible statistics that you're interested in, plus I'm sure many more. But again, this is for the whole image. So we want to set this so that we're only seeing the nuclei and then individual nuclei. And we can do that by thresholding the histogram. So just below the image area, under the tab that says histodefinition, Nicole, if we select there, you'll notice at the bottom of this tool, there's a lower threshold and an upper threshold, right? So we have to pick a threshold here that will exclude the background pixels and only include the nuclei. How do we do that? Well, if we mouse over the image, Nicole, maybe you can show folks that you mouse over the image and where the pixel value is displayed at the very bottom of the Zen window when you do that.
Oh yes, right here. So if you look down at the bottom where my mouse is hovering, that pixel value, that'll correspond with where you're at here in your image. So you can see down here, well, in the background where it's dark, we're hanging out around
somewhere under 1,000, right?
Yeah.
Easily under 1,000. Some are just over.
Yeah.
And then within the nucleus, we've got over 20,000.
Yes.
So if we set the threshold for 1,000, the lower threshold for 1,000, for example, that should easily allow us to threshold out the nuclei. Terrific. So you notice a blue mask over top of the black pixels. So if you're familiar at all with acquiring images, you have quite often an intensity indicator where some of your pixels will turn blue. That means there's a 0 intensity, and some of your pixels will turn red. That means they're saturated. That's what's going on here. So those blue pixels are below the lower threshold, and they're not being measured anymore. And if you look at the mean intensity on the table, you will see that, yep, our mean intensity is now jumped up substantially. I think a 5-fold. I think it was something like 1,000 before. I don't recall, because now we're only seeing what's in the nuclei. Now, if we combine that with a manual tool, so we draw a square around one of these nuclei, for example, actually in the histodefinition tab, because we want, yeah, there you go. You've got the square already. So you can go in and just draw a square around the nucleus. And there you're going to get a measurement of only that one nucleus. So we're combining the mask with the annotation so that we're only seeing those specific pixels. And we've got a mean intensity. Okay. I missed a Kymograph question. So there was a question as to, is there a scale on the Kymograph? And the short answer is no. You can change the scale on the Kymograph by setting a scale, but there is no time scale. So one axis is time, the other axis is displacement. The displacement, obviously, you take from the original image, but there is no time scale. So you have to know that what your frame time is on the Kymograph when you do that calculation for the velocity. Okay. You can do that just by adding a timestamp to your original data and looking at what every frame takes. So, you know, if it takes 30 milliseconds per frame, then every pixel you see on the Kymograph is 30 milliseconds. All right. Hope that answered the question. Good question, though. We went through that actually in the rehearsal, and then we decided for the amount of time it took to describe it and do it that we had to cut that out for sake of time. Sorry about that. So we got a histogram tool and we're doing some specific measurements. So we've run through sizes of things, dynamics of things, intensities of things, and then a little housekeeping on adjusting all the annotations. And again, all of this in Zen Lite, the free version of Zen available. The Kymograph was the one that I was just thinking, oh, I got to double check that. So if you're playing the home game version of this, maybe check that on Zen Lite, or otherwise I'll do so after the fact. So I think we can move on from measurement. What do you think, Nicole? Can we go do some image processing and some 3D rendering and stuff?
Yeah, that's pretty exciting. Let's move on to that.
So we're going to shut these images down and we're going to get up a nice brain slice stack. I say nice. It's not super nice, because if it was super nice, we wouldn't be able to do much in terms of processing and improving it. So this is a Z stack of coronal brain slice where we've captured a number of cells with a rather complex tree of extensions here, and we can see spines on these if we zoom in. Trust me at this zoom level, but they are there. And I guess the first thing to say is when you have a stack like this that has a lot of different information in different planes, you need to be able to convey that when you put it on a poster, or if you don't want to play through the Z stack. And what's the best way to do that? Well, we can do an extended depth of focus. So extended depth of focus is a catch-all term for doing a projection of a Z stack. And in this case, because it's a fluorescence image and because we're interested in seeing the things that are in focus, we're going to do a maximum intensity projection. So under our processing tab, we're going to search for orthogonal projection or projection, whatever you like. If you're like me and you may not be certain of the spelling of orthogonal, I guess I would have gotten the first 5 letters no problem at all. So I might have
just
an I in
ortho. That's all I typed in.
there.
It's the only thing in this processing tab that should come up.
It says orthogonal, yeah. Okay, so we've selected the orthogonal projection. So the parameters for that are below. The projection plane by default is an XY projection, which is exactly what we want. We want to see the XY projection on itself and collapse the stack into a single image. We want the method to be maximum because we're going to do a maximum intensity projection. That's exactly what we want. We want to start at the beginning of the stack, and we want the thickness of the stack to be the full thickness. So we have 31 planes in this stack. We're going to include all of them.
Yep.
There we go. That will be a maximum intensity projection if we apply that to our image. That's going to process very quickly. Oh, there we go. So we can now see the full Z stack collapsed on itself as a MIP, if you will, maximum intensity projection. Terrific. That's one way to display your data. But as I mentioned before, these images can really be improved somewhat. So let's close the MIP here, if we would, Nicole, and then zoom in really close to that Z stack and find an interesting region. And let's just take a look at the really kind of pixel level intensities and what's going on there. Right in.
This area the best.
Yeah. Even more. Go in even farther.
All right.
Even farther. Yep. Okay. So we start to see here that there's a lot of noise and local variation. I mean, clearly non-biological variation here of some sort, right? And it's just a matter of how many photons we have to work with. Almost any image you zoom in to this degree, you're going to see some of this kind of choppiness through it. How is it that we can improve that beyond what we have now? So we're going to do some image processing to show you what you might do to make this a little prettier. And I'll mention that it's exactly that. We're making this pretty. So these are not quantitative techniques. Please don't apply these and then do some mean intensity measurements, because of course we're changing the intensities as we modify the image. So we're going to do this sequentially, but I'll just mention from the beginning, we're going to do a single pixel filter, and then we're going to do a very gentle smoothing, and we'll talk about smoothing versus resolution, and then we're going to do some background subtraction. And what we'll end up with is a beautiful high contrast smoothed image that we can then do some rendering on. Okay, so processing tab, right? And let's do a single pixel subtraction or a single pixel filter here. So search for some variation of that. There we go. Single pixel filter. Terrific. Can I steal the mouse for just a second, Nicole, if you don't mind?
Definitely.
Is that okay? So I wanted to show folks, we didn't discuss this before, which is why I'm stealing the mouse. I didn't want to confuse people here, but this is a little bit of a tangent. If you don't search for anything in the methods, you see all these headers. So all these things that can be expanded here. There'll be slightly less in Zen Lite, but there's still a really extensive list of tools here. And I would really strongly suggest just going through and reading the tools that are available in Zen Lite and exploring them. And anything that you have a question about, there is a reasonable response if you use the help file. So if you go to the right, very, very top right, hopefully you can see there's a little question mark beside the Windows minimization. And if we click on the parameters window for the single pixel filter, for example, it'll give us an explanation as to what this tool is doing. Okay, sorry about that, Nicole.
No, that's great. That's a great way to impress somebody if they ask you, how did you get this image to look so pretty?
Right.
You can give them the rundown.
There are, yeah, even if it's appropriate, there are the equations for what was done in the help file generally. So in this case, single pixel filter, we're filtering out pixels that are dramatically different from their neighbors. And what happens is they get reset, their value gets reset to the median value of the neighboring pixels. And it depends on how far away from the standard deviation or how many standard deviations they are from their neighborhood. And that's the threshold that you see there. So look at the help file if you have more questions than that. But we know from experience that the default works rather nicely as a single pixel filter on this image. So let's apply that, Chantel, to our data here. And as Nicole's hitting apply, I'll point out that, you okay?
All right. Yep, we're good. You accidentally called me Chantel, but that's
Did
okay.
I say Chantel? Oh, man. I'm so embarrassed. That's terrible.
That's fine.
All right. So
just so you guys know, Chantel is our colleague who works in the Toronto core.
Yeah.
Chantel as well.
And she's also in attendance,
so
and she's also laughing her, laughing her hiney off at me right now. So thank you.
Probably.
In my defense, I have done this yesterday with Chantel. That's I'm not sure if that's a defense, but all right. So we've done a single pixel filter. Thank you, Nicole. In the column on the left-hand side, I should mention that the input window is at the very bottom of that column. And if we scroll down, you'll see I have all of my tools set to set input automatically, which means whatever the active image is what gets pulled as the input. If you do this at home and you're doing it for the first time, you have to either select the image by clicking on that square there and selecting one of the open images, or just toggle set input automatically. That's usually the way to go. You're never generally processing an image that you're not looking at, so works well. All right, the next thing we're going to do is a Gauss filter. So we're going to do a slight smoothing of this image. If you look under the search tab and we do Gauss in there, G-A-U-S-S, and set that smoothing for the minimum value possible. So a Gauss filter is a smoothing filter, and what we're doing here is looking at a small neighborhood, and then we are kind of modifying the local intensities so that they're all a little bit closer to what their neighbors are. And the result is that we get a much less noise in the image. Of course, the opposite of smooth is resolution, more or less. I'm going to say that at least. That sounds good. So if we're smoothing things out, we're losing resolution. And we need to judge this on our own images as to the size of the smoothing that we use, which is the sigma values there, sigma x, sigma y. We've set these for the absolute minimum so that we don't lose fine features. So let's apply that to the image. As we do it, if you just watch the image, you should be able to see, we're going to zoom in on these, but you should be able to see when the smoothed image pops up that we've got a pretty substantial improvement that looks at the macroscopic level. Yeah, maybe. Kind of hard to see if you're doing this on a webinar, possibly. Okay, and there's one more thing that we can do to this image to possibly improve the appearance, and that is to do a background subtraction. So even though we have a Z stack here that clearly has some resolution, axial resolution, we still have some background fluorescence. We have some things that are in focus and out of focus. And if we want to emphasize that, background subtraction is a method of going through our image and subtracting out the background, the out of focus fluorescence, with the assumption that if you have a homogeneous area of the image, that that's considered background. So objects have high contrast, background is generally homogeneous or more homogeneous. And the way that we find homogeneous regions of the image versus high contrast is we move around and look at very small regions of the image, by setting the radius. So the radius of these parameters determines the size of the image, the size of the region of the image that we're looking at. And if we look at that small region and if we have a homogeneity, then we can say, oh, this is background, and we can subtract it out. If we run into high contrast, then we say, oh, that's an object. So let's not do the object. Let's not do the contrasted area. So I think we figured that 75 was a good value for this image, and that's really a bit of trial and error, but it's a radius in pixels of objects in your image. So if you can zoom into objects of interest and figure out how many pixels wide they are, that's a good starting point. And then I would just go bigger and smaller from there. Okay, let's apply this. Okay. That will take a little bit.
Last question here. Under background subtraction, other options, say only smoothing hand, like back.
We have audio issues when we're background subtraction.
Oh, right. Okay.
So you're very choppy to me. My apologies to the audience.
Yes, likewise.
We're almost halfway done. The processing power required to do subtraction. We'll just wait it out. For the moment, we'll see the rest. Progress bar is at the bottom. You can hear me, and we're at 80% now. We're almost complete. There you go. All right. So I should have mentioned before, for anybody who didn't hear, when we do the background subtraction, it's processing intensive, and that seems to muck around with the webinar audio. So apologies for the silence there and for the choppiness, but that's the reason. It shouldn't happen again. Sound good? Nicole, you were asking a question when that went choppy.
Oh, yes, yes. My apologies. Here, under the parameters tab, there's 3 little options. So this one, do smoothing beforehand. If you were to click that, would that smooth the image similar to what our Gauss filter would do beforehand, exactly, or not necessarily?
Yep. No, that's the same idea.
Okay, it would.
And I'd have to check the help file to find out what it was using, what smoothing filter it was using.
Right.
I wanted to do it incrementally so that we could see and compare what's happening at each step.
For sure. Good to know. Great. Okay. This image looks lovely.
Yeah, so we get higher contrast. If you make a multi-image figure of this, then we can zoom in on different regions and really get a feel for what's going on across. So let's, you know what to do here, right? Yeah, you got it.
There we go.
Can we do 4 across and do each one of them?
Yep. Let me just fight the lag here, my nemesis.
Okay.
All right, so we've got 4 panels.
If we drag in the images from the right-hand side, I think the original data is probably at the top of that list. You can put it in whatever order you want, but if you don't want my brain to explode, you'll go left to right in terms of our progress. Yeah. Great.
Perfect.
And then let's zoom in on some region that will have some interesting features, some spines somewhere, something that's in focus.
I'll go to my favorite spot.
Okay.
Lovely.
I like it. even more, I would say. Let's go right in
Okay.
until we see, yeah, so we can see the features of these cell extensions. And we can see from the left to the right how much we're kind of getting rid of this speckle noise, probably most of which is shot noise, knowing how this was acquired. So noise that we can't control, noise that isn't instrument specific. And then we smoothed it out from panel 2 to 3. And this is where you have to make a judgment as to whether you can do this without losing some resolution. So we look at the tiny little features that are in this, and I think we've preserved them for the most part. We can still see pores where there look to be pores. And we've gotten rid of a lot of the single pixel variation that makes it look noisy. And then we've gone to a background subtraction. And similarly, you have to make some judgment because you are going to be erasing some features with background subtraction. But it can be very powerful, especially with wide field images. And there are other companies, competitors, other vendors who are selling this as a method of doing optical sectioning, essentially. It's called computational clearing or digital sectioning, or it goes by a number of different names. But here, all for free, if you'd like, in Zen Lite. Can you explain the display interpolation versus these adjustments? Is the interpolation coming through when you export TIFF images? Aha, yes. It's very understandable to be a little concerned to realize that Zen is interpolating your pixels as you're zooming in and out. It doesn't adjust the data in any way, and when you export images, there's no interpolation. I guess the only time that it would impact you at all would be if you're taking a screenshot, but hopefully you're not taking a screenshot of something and then trying to do image analysis on it. So that would be a poor workflow for any number of reasons apart from interpolation. So the interpolation is exactly like what happens in Adobe Photoshop, for example. If you acquire a 512 by 512 image and you want to put it on a poster and you want it to be the largest figure in the image, if you blow it up 512 by 512 to be 2000 pixels by 2000 pixels without any adjustment to it, you will see quite a bit of pixelation. And if you throw it into Photoshop and say, hey, I want to make this thing 2000 by 2000, Photoshop will interpolate the pixels, and what will happen is you'll get a smoother image. So you won't see the pixelation. That's not going to change the resolution. That's a whole 1 hour discussion about resolution versus digital resolution versus interpolation itself. But you can't measure anything that you couldn't measure before. It just looks a little smoother, a little nicer. So, okay, hope that answered it. Good. No concern about data, I guess, is the take-home message. You're never going to modify any measurements or images by using that. Okay, are we good? Nicole,
Yep.
did we got it all?
Okay.
So we're going to do some rendering.
I mean, looking at the time, what do you think?
Yeah, I think we're almost finished our Zen 3 features component, and we're going to dive into image analysis. So let's really quickly do a rendering of this background subtracted version of the image. We can close everything but the background subtracted, I think, or just go straight to the, I think that is the background subtracted there, right? Yeah.
This one here, yeah.
So if we want to do a rendering of that and an animation, we'd go to the 3D tab that's immediately to the left of the image. And when we click on that, we can see the 3D rendering, and we can zoom in and click and drag, and it'll rotate and do all sorts of great stuff for us. I'm going to suggest, Nicole, that just for the sake of having something that's not appearing so flat when we render it, that we actually go back to the 2D view and crop out a region. And that way it'll look a little more impressive when we do the 3D rendering. So pick your ROI tool and let's get a smaller region of this, and yeah, anywhere you like. So I'll point out as Nicole's doing this that there isn't any problem rendering the size of this data. And when we do the 3D rendering, you'll notice a watermark in the bottom right-hand corner that says Arrivis. So Arrivis is a company that we've licensed this rendering engine from, and they are the gold standard as far as I know and am concerned. That will allow us, or sorry, they are the gold standard in the industry for 3D rendering, and they can do multi-terabyte data sets. So there's no problem. Even in Zen Lite, you have that access to that engine. So as far as I know, this is the best free rendering you can do on the market. Okay, when we've got that rendered, there's a couple of modifications I would always make in Zen to a 3D rendering. And that is, first of all, we've got these annotations that I find to be a little distracting. Yeah, the scale bars, etc. So just below, if we click on those, we'll toggle them off. And then under the appearance tab that's just below those tools, we have a threshold set. So Zen tries to make a guess at how to enhance the contrast. I don't like that personally, so I would drop the threshold to 0 always so that we're seeing all the intensity in the image. I feel it looks a little artifactual otherwise. And then the last thing is under the 3D tab, just to the left of appearance. You're gonna zoom in a little bit there? Sure. You can drag that precise to fast tab all the way to precise so that we're not losing any resolution. Good. Yep. You want to zoom in on that?
I'm struggling to zoom in right now.
Zoom in
Do you
for
want
you?
to take the mouse and give it a go?
Sure. The way that I usually use, in part so I don't have to switch tools, is this little zoom bar here. That allows me the most control.
Okay.
You can also
Gotcha.
use the mouse wheel.
Yeah, it was, and it wasn't going, so I thought maybe it had to do with just my connection.
You probably just have to click in the image once, or maybe we had the wrong tool selected here. That's possible as well. So there we go. Okay, so we zoom in. Let's do a quick rendering.
Beautiful.
So if we go to the series here, I'll give you back the mouse, Nicole. And
All right.
we're going to animate this. So we can animate this a whole bunch of different ways. We can turn the image around the x-axis. We can turn it around the y-axis. We can do around the z. I like to do a start-stop. So if we select the start-stop here, we can position this however we want, and then we can go to a stop position that however we want, and Zen will just animate the transition between the start and the stop. So there's your start position, however you want it. And on the bottom tool menu there, you click on stop, it resets it, and just zoom to whatever rotation you want to have the stop position. And we're going to see an animation that goes through between the two. When you're ready, you hit apply in that same toolbar, and this will take a little bit of time. As I'm doing this, I should mention, if you have Zen on your PC, on your laptop, and you have an older laptop or it's underpowered in terms of graphics, you may get a message in the 3D rendering that says your hardware is not sufficient. And if that's the case, there's not too much you can do. You need to go to a workstation and manage it there. So, okay, so we've got the output. Under dimensions, this now shows up as a time series. And the time series is essentially a flip book where we've got different planes as we animated from the start to the stop position. That's it. So that can now be exported as an AVI, as an MOV, as a series of TIFFs, whatever it is that you feel is appropriate for exporting. Under the processing tab, if you search for export,
there you go.
Terrific. Okay, movie export. And I would suggest using the defaults there, with the exception of going to, I think the default is MPEG compression or MJPEG compression. I would always use the uncompressed version so that we don't introduce any artifacts. Doesn't make sense to get this beautiful image and then have some compression artifacts when you do the render. All right. I should say that we're going to end at about, I would say, 225 based on experience from doing the image analysis. So all we have left is to run through image analysis, and we're going to count some nuclei. And if people have to run because they've got somebody barking and or yelling from another room, then thank you for joining us. but if you can stick with us for just a bit longer, we'll show you some neat stuff that is the automated image analysis module, right? So here we are officially transitioning out of Zen Lite. What we're going to show you now is something that you will not have access to unless you have an existing system. So a laser-based system always comes with the image analysis ability, but also you can have a workstation that's licensed for it. So let's open up the BPAE, and this time we're not going to crop in. We're going to count all the cells in this image, and we're going to do so with automated image analysis, which is found under the analysis tab to the left here. So under analysis, the second window down is image analysis, and we're going to create a new image analysis setting. Great. So to the cog wheel to the right-hand side of where we say setting, we say new, and let's create something descriptive for our cell counting. And once we've got that saved, we're going to go to set up image analysis at the bottom of the list. Terrific. And that's going to take us into the image analysis wizard. So this is a 7-step wizard. We're only going to do things in maybe 3 of these 7 steps, but we'll describe each one of them briefly. This is a very important step to make sure that you understand and get correctly. So we have a list of the features that we're going to examine on the top here. One says classes 1 and the other says class 2. This is a very non-intuitive naming. So we're going to change these names if we could, Nicole, and we'll say the class 2. You're going to change class 1? Okay. So this is the image level. So we can call that the field of view or the image. Great. And class 2, this is the object level. So we're going to call that nuclei or objects or whatever you want to say. Right. So whenever we're dealing with the whole image, so properties of the whole image, those properties are associated with the first line, the FOV line, field of view line. And whenever we're dealing with properties associated with individual objects, that's associated with the nuclei line. One other thing we have to do is make sure that we're actually looking at the channel of interest for the nuclei. So we've got channel DAPI selected. That's correct. Yep. And if we wanted to change that, it would be just to the left of the mouse there, but we don't. That's good. And then we have to select a mask. So we have to pick a mask color there that is something that's not used in the image already is probably preferable. And also not white, because we're going to have some annotations that are white regardless. How do you feel?
How's
like
turquoise sound?
Turquoise? Okay. I'm feeling turquoise today. Sounds
It's
good.
springish.
It's springish. Yes, I agree.
Yeah.
Okay. So we've set up our nuclei. We're using the DAPI channel. We're going to color them turquoise when we identify them. So we can go on to the next window. The next window lets us interactively adjust the region of the image that we're measuring. We're not going to do anything with it, but if we wanted to, we could draw a shape in here, and we would only do the analysis within that shape. I do want to point out that the top left-hand corner of the window has this little button that says interactive. And if we've got that checked off, then when we run the analysis, we can run it in interactive mode, and the analysis will stop at any window that is interactive so that we can modify the analysis. So if you were doing this on, say, 6 different brain slices in a row and you had different regions for each slice, or each image, the image analysis, if you check this off, would stop, allow you to draw the region that you wanted to do the analysis on, and then proceed once you said, okay, I'm good. For us, we're going to do the whole image, so we can go on to the next step. Okay, in the next step here, this is the most important probably in order to set up our image for analysis. If you don't mind, Nicole, let's get only the DAPI visible here.
Oh, sure. Yes. Let me unclick those there. Yeah, there we go.
So here we're doing very much like what we did with the histogram, initially at least, where we're setting some thresholds to determine what's a nucleus, what we want to identify as an object. And it's very easy to do. All we have to have Nicole do is click on the nuclei. And as she clicks on the nuclei, the value of the pixels underneath where she clicks are going to be included in the range of acceptable values. So as she clicks around, that range will get bigger and bigger, and we will see more and more pixels that are valid, which means more and more nuclei. Terrific. Having done that, we can see our nuclei are set. We're good. But I do want to point out on the left-hand side of the image here, halfway down these image segmentation window, we have the thresholds that we've set. So 10,596 and 40,294. First of all, I would say we can ramp up the 40,000 because we don't care if it's too high intensity. So you can grab the other upper limit on the histogram bar there, Nicole, and just drag it all the way to the right. And that'll take care of the upper limit. Terrific.
Perfect.
But I want to point out that those thresholds, if we use this in the image analysis, those thresholds are going to be applied to every image. And if the image conditions aren't the same, if we've underexposed or if we've, somebody diluted the DAPI stain or something like that, then these thresholds may not be appropriate. So there's another way to do this, and that's to have the system calculate an automatic threshold. Nicole, if we could just destroy your hard work here, if we would, by to the right of where those thresholds are, could you select full range and then invert? And so that'll erase all your thresholding. There you go. And the reason I want to do that is because you did a great job, and if we just clicked on automatic and nothing happened, people would be confused as to what was going on. But if we click on automatic now, we'll see that we get the thresholding. So there's a number of different ways for the thresholding to be calculated here automatically. That's the method, which is just below the automatic button we clicked. But for a high contrast fluorescence image, Otsu threshold works very nicely. And the help file is your friend if you want to figure out what math is being used for each one of these. In short, we're looking at peak intensities and calculating standard deviations or something like that away from peak intensity. So that's how the Otsu is seeing these. There's a whole slew of other things that we can do to this image: smoothing, sharpening, thresholding on minimum areas, that sort of stuff. For the sake of time, we're going to skip over that. Most of them are self-explanatory. We may do a separate Explore Zen that discusses these and go more in depth in image analysis. But I think for now we're set. We see our nuclei. We've got a good threshold, and we can go on to the next step. What do you think, Nicole? Are we looking good?
Yeah,
Did we miss anything?
Yeah.
Okay.
No, that looks good.
So the next step gives us the ability to filter this image. And the reason for that is that even though we see pixels of a certain intensity, we may have things here that are not really nuclei. And I think, Nicole, knowing this image, if we travel to the right a bit, can you zoom us over somewhat and maybe up? I'm not sure where he is, but somewhere in here there's a real funky looking, there it is, yeah. So kind of at 12 o'clock in the image, there's a non-nuclear looking nuclei. If we want to see what that looks like a little bit more, just below the image, there's a button that says fill. And if we uncheck that, you'll see what's happening under the mask with just outlines. So that clearly is not a healthy cell, or maybe not even a cell at all, maybe some sweater lint or other debris that's fallen into this, who knows? But we don't want to count it. And so the idea is that we're going to create a region filter, which is going to say, okay, we need to have these properties of an object for it to be a valid object. And to set that, on the left-hand side of the image, we're going to click on Edit, and we're going to get a whole slew of measurement features that we can use. Now, I've used this image analysis to count nuclei more than twice, so I happen to know that using the circularity of an object is a really good way to see nuclei and exclude non-nuclei, and also to look at the standard deviation of intensity. So if we could add standard deviation, and I'll mention that you can search for any of these just above the list. There's a search bar as well. The standard deviation, the concept is that it's reasonably homogeneous within a nucleus, and then if you have some sweater lint, it tends to be like really bright and then dark and really bright, so it varies. Okay, So we've created these filters, and notice that the mask has now gone from the beautiful spring turquoise that was selected to a white. So all of these objects are currently invalid because they don't fall within the filter. Yep, wonderful. If Nicole starts clicking on objects she considers to be valid, then we will change the filter values and we'll start to see things that are in fact counting as nuclei. And you'll notice on the left-hand side that the parameters that are acceptable for circularity and intensity are expanding the same way that when we were thresholding pixels, they were doing so. Good. So we're excluding our funky looking guy there. Now, if we move around, Nicole, we may not do the analysis because we only did the thresholding on a subsection of the image. So if you're confused as to why some things are not masked now and other things are, that's the reason. We'd have to click back to the thresholding and then come forward again. But it doesn't have a negative impact on the image analysis, so we can just leave it as is. So let's go on to the next step. So here we can do interactive segmentation, which means that we're going to add or erase or merge objects. We're not going to do that. Again, it's interactive, so we can put a little check mark if we want to, but we can actually move on to the last step here, which is what data do we want reported? So remember I said we had two lines. One line is the field of view, the other line is the nuclei. And if we click on the field of view line, we'll see the data that's going to be reported on the image level. So by default, the data for the image level is count. If we click on that edit button, we will see a whole list of data that we can pull out of this. So the percent area that's taken by the objects, for example, the number of objects is the count, parameters about the height of the image or the size of the image or anything that is done on an image level is here. I don't think there's anything that we necessarily want to add. Oh, you added area percentage. Great. Okay. So let's say okay to that and then move on to the nuclei data. And the default for the nuclei data is that we get the area and the ID. If we want to have something appear on the image for each object, that is the annotations. There's nothing listed in the annotations. So you notice there's two edit buttons here. The top is for what we're measuring. The bottom is for what we're annotating. Maybe the top edit button, we click on and add the mean intensity, because I think that's what we said we were going to measure here. We were going to count cells and also measure the mean intensity of nuclei. Rather extensive list. Keep in mind you can use the search bar at the top if you would like. There you go. Intensity mean value of DAPI. Wonderful. Okay. So we're set. We've got what we want to measure. You can click on next, and step 7 of the wizard is a preview of the data. We're only previewing this region that we're looking at, so that's not very exciting. So if we click finish, we can analyze the whole image just by clicking on the analyze button under the image analysis window, and that will spit out the full analysis of the full image. Terrific. So it looks like we had to expand our filter a little bit because we missed some of the nuclei there. But this is usually an iterative process where we go through and we see what we get, and then we kind of go back in and say, okay, we got to tweak this or that. Helping with that is the data that we have on the right now, because we can see the plot and we can see if we have any outliers. A really nice aspect of this that if we find an outlier and we click on it, so go ahead and click on that button or that little tag there in the scatter plot. Then you'll notice in the image and in the data table that we've got a highlighted nucleus. So that outlier is that nucleus, and we can see all the measurements that are associated with it in the data table if we want to. We can change this plot as well. So right now we have area versus ID, which is not very exciting. So underneath of this in the custom chart area, We can change what's plotted. And we had the mean intensity. So what if we do mean intensity versus area maybe is more interesting. There we go. Different scatter plot, different outliers maybe. We can play with that. And then of course the data table can be exported just as before. So under the analysis tab, just to the left side of the custom chart, there is a create tables. And if we click on that drop down, we can say the nuclei table. And just as before, we can export it as a CSV. Very good. I think that we have covered it.
Awesome.
So thank you everybody for sticking with us there through that Explore Zen session. Somebody did ask a question right near the end there, asking if there was going to be a recording, and this is being recorded. I should have mentioned at the beginning, and at the moment the intent is to mount this on my YouTube page and provide you with a link. So all of the people who attended here will have a link to go through this again if you'd like. All right. I think we'll wrap it up. Nicole, anything else you want to say?
Thanks everyone for attending today. I really appreciate your participation, and feel free to reach out with any questions that you may have.
Okay. All the best, everyone. Stay safe. Talk to you soon. Take care.
Have a good afternoon. Bye-bye.